Math is a wonderful thing. Math is a really cool thing. So get off your act, let's do some math. Math, 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 math.
We're going to learn how to draw an algorithm for question 5.56 out of the textbook. Question 5.56. Will taking antioxidants help prevent colon cancer? People who eat lots of fruits and vegetables have lower rates of colon cancer than those who eat little of these foods. Fruits and vegetables are rich in antioxidants such as vitamin A, C, and E. Will taking antioxidants help prevent colon cancer? A clinical trial studied 864 people who are at risk of colon cancer. The subjects were divided into 4 groups: daily beta-carotene, daily vitamin C and E, all 3 vitamins every day, and daily placebo. After 4 years, the researchers were surprised to find no significant difference in colon cancer among the groups. So to draw an algorithm, you're first going to say 864 people, because that is the amount of your sample. And then you're going to say randomly assigned, because they're going to be randomly assigned to their treatment groups. So now you're going to split them up into 4 different groups, because that is what is listed in the problem. And we're going to label them Group A, Group B, Group C, and Group D. And then we're going to specify the amount of people that are in each group. And because there's 864 people and 4 groups, there's going to be 216 people in each group. Now we're going to specify which treatments the groups will receive. So Group A will receive beta-carotene. Group B will receive vitamin C and E. Group C will receive all 3. And Group D will receive the placebo. Now you're going to specify the next step in the treatment, which is the waiting the 4 years. Oops. Oh well. And then after that, you're going to compare the results. To see if the amount of colon cancer changed in the patients, which according to the researchers, it did not. The only thing that you need to do after you draw the algorithm, which is this diagram, is a couple of sentences specifying how you randomly assigned your subjects. This can be done by having an alphabetized or list of all the subjects, giving them a number, and then using a random digit table to assign them to the different groups.
And now for a second example, we will do 5.58 from the textbook.
Acculturation rating. There are several psychological tests that measure the extent to which Mexican Americans are oriented towards Mexican, Spanish, or Anglo-English culture. 2 such tests are the Bicultural Inventory, or BI, and the Acculturation Rating Scale for Mexican Americans, or ARSMA. To study the correlation between the scores on these 2 tests, researchers will give both tests to a group of 22 Mexican Americans.
To initiate the algorithmic process, we begin by giving a random group assignment to 22 Mexican Americans, which is our sample population. We divide them into 2 groups, which we will label Group 1 and Group 2. Now, since both sample groups will be receiving both tests, this is a matched pairs design, so we have to randomize some element of it, in this case, the order of the tests. We randomly assign people to Group 1, where the bicultural inventory test is taken first, and then the acculturation rating scale for Mexican Americans, and the other group will receive a reverse treatment. For the next step, we record the scores for each group. And we finish the process by comparing the results. It's worth noting that at this point the process is done other than giving an explanation as to the randomization process used in the random assignment of groups and the random assignment of order of tests to each group. Generally, this will be done using digits from a random digit table.